Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. Thanks for joining us today. I'm your host, Henry Regis, and behind the scenes running our technical side of the program are Zach Schwalbe and Noah Newman. We're coming to you live from the Colorado Climate Center here in Fort Collins, Colorado at the Colorado State University on what is a drizzly day, but there's actually a forecast of snow for tonight and tomorrow morning. Wow, September 11th already looking at snow. For those of you who are unable to join us for our live broadcast, we'll be recording it for future viewing on our website. All of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, today we're going to take a look at a day in the life of a National Weather Service forecast office. Have you ever wondered what actually goes on there, what they do during the day, how they make their forecasts? Well, we'll have all that information for you here shortly, as we have John Gordon joining us today. And John is Chief Meteorologist at the National Weather Service Forecast Office in Louisville, Kentucky. John holds degrees from St. Louis University and Mississippi State. During his 21 years as a U.S. Air Force Reserve, he was a flight meteorologist. He's flown missions through several major hurricanes, including Katrina in 2005, and John helped spin up the new Huntsville National Weather Service office in the early 2000s and has worked for the National Weather Service and Air Force in Oklahoma City, Germany, Jackson, Mississippi, Springfield, Missouri, and Nashville, Tennessee. Well, welcome, John. It's great to have you with us today.
Thank you so much, Henry. I'm very
got a phone ringing in the background here. Let me shut that off. Go ahead.
I'm very excited to be with everybody here. I'm a big believer in weather. Thank you so much for Henry and Nolan and Noah for inviting me. And for the next 30 to 40 minutes, we're going to have fun looking at the day in the life of the National Weather Service. I personally got into weather because of Agnes, Tropical Storm Agnes in 1972. And during the 1970s, as a kid growing up in western New York, I got to see some amazing things happen. For those who are a little older on the CoCoRaHS community, the wreck of the Edmund Fitzgerald on Lake Superior, the Big Thompson Canyon event in the mid-1970s and not far from Henry and Nolan, Hurricane David, a lot of blizzards, the blizzards of '78 in Cleveland and in New England. So I've always been fascinated by weather, and it's pretty cool that you can get paid to do your hobby. And I appreciate all you observers out there that give us critical data day in and day out for the operations of the Weather Service. So we're going to start here with the day in the life of the Weather Service. Like Henry said, I work at the Weather Service office in Louisville. The second slide that you should see up on your screens is the Weather Service 122 field offices. I think the strength of the National Weather Service is in the local communities. As you can see on this map, the Weather Service serves everywhere from Caribou to San Diego and from Seattle to San Juan. We have offices across Alaska, American Samoa, Guam, office in San Juan, Puerto Rico. And with those offices closest to the community, we're able to provide a lot of information. In many journal articles, the Wall Street Journal, et cetera, talks about the efficiency of the National Weather Service with its employees dedicated to service providing. We're 24/7, gang. That means there's folks here on Christmas morning, on Thanksgiving Day, in the middle of a tornado event on New Year's Eve, whether that may be. There's always weather going on, and it's the dedication of the folks at the Weather Service offices providing that information to help protect life and property, and that is our mission day in and day out. That's our office there in center part of Kentucky. Most people don't know this. I know Henry loves these little factoids. There's 5 offices that serve Kentucky. We have 120 counties. You look at the size of Kentucky, you think, well, how can that be compared to like Texas and Georgia? But we have 5 offices that service the Commonwealth, 3 in the state in Paducah, Louisville, and Jackson, and then Wilmington, Ohio, and Charlie West handles the far northeast part of the state. And then you look at states like Texas, you can see states offices in Amarillo, Lubbock, Midland, San Angelo, San Antonio, Corpus Christi, Brownsville, Houston, and Fort Worth, and part of Shreveport owns the eastern part. So you can see the diversity of how many different offices cover the state. And then you have, like in Utah, for instance, Salt Lake City covers the vast majority of the state, with Grand Junction covering the eastern part. So we'll move on to the next slide. This is my area, just to show you what a typical office is like. We cover 2 time zones. That is a problem at times. We have people that program our weather radios and also maintain our warning equipment to figure out what time it is. It's always been a joke of mine in Indiana of what time it really is in Indiana. When I first came here, we had some counties that do CST, some counties did CDT, some counties did EDT, some did EST, some did none of the above. Thankfully, after some intervention from above, we now have just one time zone. It goes EST and EDT, with the exception of Perry County for us, which is an Eastern time zone, so, or rather Central time zone. So that's our area. We have 2 states that we cover. There are a couple Weather Service offices in Paducah, for instance, and in Memphis, Tennessee, that cover 4 states. That's a lot of extra work for the offices. Everyone from the service hydrologist, who has to work with partners in the USGS and Corps of Engineers, to the Warning Coordination Meteorologist, who deals with emergency managers and members of the media and various other partners. So it's always, every office is unique and different. In our office, we have 59 counties, 49 in Kentucky, 10 in South Central Indiana, almost 2.8 million people from a census. We service some of the areas in Louisville, Lexington, Frankfort, and Bowling Green are some of my bigger communities and bigger cities. Louisville's the biggest. And compare that to Los Angeles, which has a population base almost quadruple mine. So it's all different perspective in the area. You see this logo on the lower left, that's the Weather Ready Nation initiative across the nation, where we're trying to be better prepared with communities and get people prepared before the storm, during the storm, and after the storm, with a lot of initiatives, and nothing has changed. The mission of the Weather Service has always been to serve the people, but with the Weather Ready Nation, we're trying to get people better prepared for the next hurricane, the next flash flood, the next big heat wave, whatever it may be. Okay, the next slide is what the Weather Service looked like before 2000. On the left, you see how it used to be. We used to have a surface observing desk where you had barograph trace or anemometer trace and thermistors and hygrometers for dew point. They used to take observations. That was their main job. There was a human observer that would go outside and measure the weather, whether it be the cloud ceiling height, the visibility sector compared on the runway, where they would look at different aspects of the airfield. If, for instance, if the tower was a quarter mile from the office and they could only see the tower, the visibility would be a quarter. If they could see maybe perhaps there was a hilltop nearby that was 3 miles, they could see that, but they couldn't see beyond there, that would be a 3-mile visibility. Now we have ASOS, which is the Automated Surface Observing System, which measures a variety of parameters from pressure and temperature and dew point and wind speed every 5 to 10 seconds, sometimes 30 seconds. So that has changed. On the lower left is the, believe it or not, we used to do 8-tracks. I know, Henry, you remember them. We had 8-tracks, weather radio recorders, people that would just read the weather on the 8-tracks in a soundproof room. On the upper right is, I remember doing this. I also did the weather radio, and I did surface observing. But on the upper right is, you saw the map room. People would come in there. I had a coloring box, which I brought to work, which seems preposterous in 2014, but that's how it was. And you would hand analyze maps. You would look at surface maps and upper air maps. You would look at instability and pressure and moisture advection, and then all types of different things. And part of our job duties when I first came into Weather Service in 1993 was we would analyze the upper air maps. There's about 60 sites across America where we launch balloons twice a day at 0Z and 12Z. And about 2 hours later, the next thing you know, the maps were in, and somebody would analyze the upper charts. That would be 500 millibars, which is about 18,000 feet, and 300 millibars, which is at 30,000 feet. And then somebody would do the lower levels, 850, which is 5,000 feet, and 700 millibars, which is 10,000 feet. Someone would do a surface map. We'd compare the notes and do an update to the forecast. Things have certainly changed. In the lower right, even though that picture's lit up, that's normally a dark room. We used to have a 1957 radar, basically a Korean War vintage radar that we would use to, you'd go in there and it would be completely dark. You'd come out of there after so many hours of severe weather and get blinded by the light, so to speak, that song, and you could be in that office for long periods of time. You had a range height indicator scope, you had a plan position indicator scope where you would look at the echoes, look at the intensity, try to figure which ones were the worst cells, and you'd actually encode them up from 0 to 6. Anything that was 5s and 6s were very bad. XXXA. So things have changed. Moving on. Now you see the Doppler weather radar map there across the nation in Guam and Hawaii and Alaska, offices in Maine and Florida, Texas, out to the California coast. Without the Doppler weather radar is probably the most important piece of information we have of all. Our number one job, my philosophy here at this office, is to focus on the short term. We want to get the forecast right. People want to know, do I need an umbrella? Do I need a coat? Do I need a sweater? Is it going to rain tonight? You know, whatever it may be. But above all, the most important part is the shorter part of the short term. Is there any warnings that need to be issued? And the Doppler weather radar allows us to look at motion to and from the radar. And by looking at that, and a lot of training we go through. In the Weather Service, we have a Science and Operations Officer, the SU, who provides training to the offices, to the staff at the offices on the various aspects of winter weather, heavy rainfall, hydrology, and convective weather. You've heard about tornadoes this past week in North Carolina, up in Missouri, southern Iowa, flash flooding in the Northland, terrible flooding in Phoenix from the remnants of Norbert all across Arizona, Utah. So without the Doppler weather radar, and I want to make sure you guys know that, we have 3 electronic technicians. We have an electronic systems analyst, an ESA. We love acronyms, by the way, for the jokesters in the room. I always say that NOAA, N-O-A-A, what does it stand for? The National Organization for the Advancement of Acronyms. So if you're laughing, you can laugh out loud. But anyway, we have 2 electronic technicians under the ESA that maintain this giant golf ball you see there on the right. Without them, we can do nothing. They are the backbone rather, of keeping our equipment going. So we'll go through this in the talk. I showed you what the Weather Service used to look like. Now look at the Weather Service of today. We have this AWIP screen, this Advanced Weather Interactive Processing System. It gathers all this data. Satellite, you see on this screen, some model data on the second screen. Here's some water vapor imagery on the left. Here's a text window on the right. We issue all of our watches, our warnings, our updates, the statements, to anything in meteorology and hydrology. And later on in the presentation, there's going to be 3 slides where our service hydrologist, Mike Callahan, is going to speak on hydrology. We do graphical weather forecasts, and we look at all this data. But it all starts with the upper air balloon. At about 60 offices across the country, they launch weather balloons, and across the world, Europe, Asia, everyone launches balloons, all the countries of the world just about. And we use that data to analyze. You'll hear on TV, well, the model said this, well, the model said that. They can do nothing without that upper air balloon. Close to Louisville, the nearest upper air offices are Nashville, Wilmington, Ohio, Central Illinois, and Little Rock comes to mind, Jackson, Mississippi, Birmingham. I used to launch balloons in Jackson, Mississippi many moons ago. So we get that data, it gets processed with high scientific equations to try to forecast what the weather is going to do through time, but it's the human intervention of the forecaster that looks at that data and tries to make sense of all this information. I never thought I'd say this, but when I started out in weather in the mid-'80s, we didn't have very much information. We had very primitive models. We did the best we could, and boy, today we actually have too much information. And yet we still have deadlines we have to meet to get information out. So we have to kind of like MASH, the TV show, with the triage, and go through this data and process as much as we can. And we continually update the forecast. Years ago, we had 2 main forecast packages at 4 a.m. and 4 p.m. Eastern Time. And now the forecast is really a living, breathing entity where we're updating this as needed. And we're trying to be proactive and not reactive. All right, we'll move on to the next slide. This is the point-and-click forecast. I'm showing you a little bit about what the Weather Service does. Then we're going to go to the forecaster duties and the hydrometeorological technician duties. On this map, this is at weather.gov/Louisville. You can hit weather.gov, and then it will be a national map, and click anywhere you want in America, whether it be Truth and Consequences, New Mexico, or Intercourse, Pennsylvania. It doesn't matter where you are. You click on it, and you can get a forecast. So on this map, you just click. I happen to click on Lexington, home of the UK Wildcats. You click on that, and you instantaneously get a 7-day forecast on the left side that's text-based. If you don't like text, well, guess what? We got graphical for you. Here's the same forecast for the overnight. It's clear here, and it's clear here with a picture of the moon. And this goes out 7 days. Here's the current conditions, the radar, the satellite, and this down here is where you can zoom in the county. You can zoom down pretty much down to the street level and get that forecast for you. Down here on the lower left is the graphical digital database where you can look at 7 days of forecaster interpretation on everything from max and min temperatures to the dew point to the relative humidity to any weather. For the CoCoRaHS observers, weather can be anything. Drizzle, haze, blowing dust if you're out in the southwestern United States, blowing snow if you happen to be in the northern United States, smoke if you happen to be near a forest fire like out in California right now. So all different types of weather they have to forecast out 7 days. So everything's on that weather.gov page. Now, this is a topographical map, and this is puny compared to the offices that have very, very complicated terrain. Kentucky has a small amount of complex terrain, but if you're in Alaska, the offices in Fairbanks and Anchorage, the Juneau office, the offices in Seattle and Portland and Pocatello and Salt Lake City and Grand Junction have very, very complicated terrain. So let me just show you this. This is Paducah's office in the west. The center part is Louisville. Here's Wilmington up in the north. Here's Jackson. The blue is the higher elevations, and then the greens and reds and yellows. So on this map, you see a temperature difference. Let me go back. Oops. We'll go back. You can see a large-scale temperature difference from 1,600 feet in my eastern area to 320 feet to my western area. On a clear, cool, radiational night in October, often you'll see 20-degree differences. Now, if you're in one of those complex terrain places like Pendleton, Oregon, or Anchorage, Alaska, oh my gosh, you can have 40-degree temperature differences at night, perhaps more. So they have to forecast for that. And that weather forecasting, if you want to get humbled, weather forecasting will give you a lot of humble pie. Everyone's an expert until they sit in the desk and go through this. I can tell you that first off. Weather's very humbling. Okay, the next slide, the real time here. We coordinate with the members of the media. One of the most often questions I get is, how much does the media rely on the Weather Service? Well, every station has a different philosophy and a different news director and a different general manager. We provide information. We do everything from chatting with them in a chat room to talking to them on the phone. It is to our benefit and to the station's benefit that we have a very harmonious relationship where we listen to their concerns. We don't always get it right. We fix when we make a mistake, or it's nice we get a lot of compliments on our office here from the media. So we're doing some right things. And then we work with emergency management. This is the State Emergency Operations Center in Frankfort, Kentucky. We actually send people there now doing some decision support stuff for big events like March 2nd, 2012, where we had the Henryville tornado and the West Liberty tornado. If there was a big blizzard, everyone heard the famous term, the polar vortex. I went to the mayor's office here in Louisville, and I know our Warning Coordination Meteorologist went to Frankfurt, just on the biggest of the biggest events. And then that's us on the right at the Weather Service office. With all of us in sync really help to protect life and property. We are a team. Okay, now we're really going to get into the heart of the forecast that you all paid and signed up for here. Forecaster task. So when you walk in on shift, first off, we have 3 shifts a day. They cover rotating shift work. So if you're a weather weenie, a weather nerd out there, and you want to get in the game, first thing is, if you got to get a degree in meteorology, which requires a lot of math and science. A lot of calculus have done a lot of people in. And second thing is, can you work shift work? Can you handle working midnights and evenings and switching back and forth? So they come in at the beginning of the shift. The day shift goes from 7 a.m. to 4 p.m. The evening shift is basically 3 p.m. to midnight, and the midnight or graveyard shift starts at 10 and it goes to 7 in the morning. So first thing is they got to check the website. Is it current and up to date? You see some headlines here, 24-hour rainfall and the July summary on this graph. The products up to date, the grids on the National Digital Database. Is the products up to date? Here's the area forecast discussion, which is one of the most popular products in the Weather Service. And then here's our weather story, warm and dry in this particular case. And we just try to give you some quick hitting information, focusing in on the short term. Now, if there's nothing going on in the short term, and on day 4 we're expecting a major heavy rain event with flash flooding, we're going to talk about that. Okay. So at the beginning of the shift, we got to check the ongoing weather. Now, you've probably never seen anything like this unless you're a pilot. This is the aviation forecast, which probably looks like a bunch of mumbo-jumbo and Greek letters to most of you. This is Stanford Airport, SDF, and the forecast valid from the 3rd, and this is at 11:20 Zulu. Basically, this is a 24-hour, in Louisville's case, a 30-hour forecast, but all the other ones are 24-hour, of what is the expected aviation forecast. They want to know just what's the wind. You can't just say north. How much is it? In this case, there's not much wind at all. In this case, there's winds are 030 at 7. That's northeast at 7. Unrestricted visibility and clouds scattered at 5,000 feet. We have a little fog here, BR. We use the international coding for what's called the synoptic weather codes, everything from BR, which is fog, to SN, which is snow. Most of them make sense. Some of them are very obscure. I think there's a lot of French involved in the words. K is smoke, and Henry will give you a quiz at the end. Anyway, Lexington's got 3 miles in fog here at this particular case, so they got to do the aviation right away to make sure that's up to date. Here's the graphical forecast on the grids. This is wind. They have to check to make sure the current forecast represents the actual weather. If we're saying it's clear out, and you hear on your favorite oldies channel and it's cloudy out, we look very foolish. So we want to always keep the forecast up to date. And sometimes the worst thing you can almost say in weather is this forecast is in perfect shape, nothing can go wrong. You can almost hear that doo-doo-doo-doo in the background from Rod Serling going, uh-oh, what could go wrong here? So in this case, here's the grid. The winds are from the north to the northeast. It looks like about 5 miles per hour. Okay, this is another thing that comes from the forecast grid. This is a meteogram. You see this top line here. This is temperature. We also have the dew point line right here. In this case, this is the surface wind and gust. This is on our webpage. This is a really cool thing. If you guys want to look at a quick graphical, let's say you want to look at, I don't even know what day this is, August the 5th, which has obviously happened. What's the precipitation potential here? Well, it's about 3%. Odds are it's not going to rain. Relative humidity, though, is pretty humid, 78% at this particular case. This comes right off the forecaster's grid, which they use a lot of different information to come up with this forecast. Okay, another new thing in the Weather Service, which I know you see this on TV, but this is a big change for us, is the webcams. We have this program we run called Hunter Gatherer, which we have in Louisville. I think we have over 200 sites where we have web cameras. We use this because it helps us diagnose fog or snow. Unfortunately, you CoCoRaHS observers are awesome. You've been trained. You measure precip, rain, snow, hail, and you report in. But we have some phonies out there that like to send in false reports. It's very aggravating. We get reports of flash flooding in a parking lot. We look at a webcam. We see the same parking lot, and there's no flash flooding. That's very irritating, to say the least. So we use the webcam. This is at a golf course, and you see some high-level cirrus clouds there. None of these are exciting, but we use webcams to deal with cloud cover, fog, snow, road conditions are a big deal. In the old days, the Weather Service was more focused on the criteria. For instance, here in Louisville, we need 4 inches of snow in 12 hours for a winter storm warning, and we need greater than or equal to 1 inch for a winter weather advisory. But at a ½ inch of snow, where the temperature drops 5 degrees at sunrise, the roads will be a sheet of ice. It will not be good. as George Bush Sr. would say, not good, very bad. But anyway, so we use that. Okay, next one. How do the previous forecasts verify? Which models have been doing well? We have a bunch of highfalutin statistics that keeps track of our forecast along with all the other models' forecasts. You can see this long thing, which will probably hurt your head, from the official forecast to the what's called the GFS model, to the Canadian model, to the European model, whatever it may be, of how they're doing and what their bias-corrected errors are. And they will use this to see which ones are performing the best. It makes sense, like you're making a recipe at home on a cake. You want to hit the one that hits the best recipe with the family, not the one that burned everything. Okay, the next one is you're starting your shift, you want to read you get a briefing from your previous crew. They want to read their area forecast discussion and get their insights. You look at the guidance from the national centers, which another thing I want to plug. Another great tool for the Weather Service office is NCEP, the National Centers of Environmental Prediction. We look at the National Hurricane Center in Miami. We don't have hurricanes here, but I guarantee if you're along the coast, you read their stuff. The Storm Prediction Center, SPC, which is in Norman, Oklahoma. Rush Snyder's the director there. We have the Space Weather Prediction Center, the Aviation Weather Prediction Center, and we use all this information to help us try to diagnose the biggest threats. High-impact events are the bread and butter of the Weather Service, whether it be a major tornado event, a major flash flood event, whatever. And today's the anniversary of 9/11, so I hope everyone today has a moment of silence to remember those who died. The Weather Service provided support that day in New York City and in Washington and also in Pennsylvania to the plains. And we do that more and more now of doing this offsite support. Here in Louisville, we go to the support the Derby, the Kentucky Derby, the Kentucky Oaks. One of the largest fireworks show in the world is Thunder over Louisville. Will actually be down at the waterfront. If there's thunderstorms, you got 800,000 people at the waterfront. That's not a good scenario. Okay. All right, forecaster test. We look at the current data. This is just a simple visible picture, a satellite. We only get that daytime. If anyone tells you they have a visible picture at night, they're pulling your leg. But we try to monitor satellite radar trends, observations. The Kentucky Mesonet here in the state is a huge asset for us of getting basically data every minute across a bunch of sites, across 60 sites across the state. We use webcams and we use the satellite. If there's going to be a big event, we can then request what's called rapid scan, where they'll send the satellite data even faster to us and will help us diagnose of an area of convection if it's going to go or not going to go. Radar trends. This picture right here, I don't even know. Let's see. Oh, it is March 2nd. Well, that's what I thought it would be. We have 3 supercells here. Radar interpretation, basically, this is reflectivity, which is measure of the intensity of the returns you're getting from the Doppler weather radar, or in our case at Fort Knox. Blues are real light, and greens are light rain, and then the yellows are it's raining pretty good, and then the darker yellows it's raining pretty heavy, and then in these reds you can have rain and very, very small hail, and then you get these little magentas, blue magentas. That's usually an indication of very, very heavy precipitation and or hail. This is probably hail in here. And if you look at the structure right here, it's kind of got like a hook feature. A hook feature as a supercell, rotating thunderstorm. And if you're going to have a tornado, it'll usually be in that spot right there, and right there. And this eventually became the Henryville tornado. Okay, another thing we do, I mentioned earlier about those weather balloons. We get weather balloons from the what's called radiosondes from these locations that launch upper air balloons. And then we get data from aircraft, such as UPS here in town, Randy Baker's group. We get weather data from them, which is basically this line on the right, that's temperature. The line on the left is dew point. The closer the temperature and the dew point depression are together, there's clouds and moisture. And you can do all kinds of weird things. You can say, I'm going to lift the parcel of air from here up, and then it gets up here, and you get some positive energy. And, well, now I've got instability. We look at this for instability, moisture, amount of water in the atmosphere. The winds here, if you notice, are from the southwest here, then they're from the west-southwest, and then up top, each one of the triangles is 50 knots. So up here you're getting 90 knots or so. I don't even know where this is at. Oh, it's at Nashville. Okay. The models, We look at all the information from the models. You see this is the American model, the GFS. You can get a kind of a cruder presentation, and then you can kind of load the image where you just look at the specificity. This is precipitation. This is just a model forecast. We do a very good job in the Weather Service on big systems. We do a good job usually on systems in the fall, in the winter, and the spring. I think summer thunderstorms are the hardest of all to forecast. Yeah, we put a 20% chance of rain in at Nolan's house or Henry's house in Colorado, but that just means there's a 1/100th of a chance, 1.01 chance of getting precipitation in that area at any point. And it's very, very problematic to see if it's going to be at Noah's house or Henry's house or my house. So you would think that would be easy in the summer, but it's usually a lot more challenging. Another thing they do is they coordinate with the surrounding offices. This is called 1-2 Planet. These are offices that talk to one another. Here's St. Louis talking to Springfield. Here's Indianapolis talking to Central Illinois, Paducah, Louisville, and who is that? And Wilmington. Here's Wilmington talking. I'm just seeing if there's anybody else. Here's SPC, the Storm Prediction Centers, talking to a couple different people. So we talk on the phone. We talk in chat rooms. We talk through social media. Some offices still use the Emergency Broadcast System, NWS. So there's lots of different ways to communicate. Another thing we do, which, you know, Facebook and Twitter came upon us pretty rapidly, whether it be Facebook or Twitter or our chat room. The NWS chat has members of emergency management, media, private weather companies, storm chasing companies, whatever it may be. And we communicate to exchange information back and forth. A reliable report will save lives. Somebody who sends a bogus report can cause duress unnecessarily. Facebook and Twitter, we can get information out very, very quickly. We have to dissect it. In this office, we've actually took a thing from the Nashville office on this social media liaisons, where we have some real dedicated weather folks who try to filter and be truth detectors and quality control some of these reports. So that's going to keep getting bigger and bigger. So if you're not on the bandwagon with social media, I'm telling you, it's going to get bigger. I don't know what the next gee whiz thing's going to be called, but it'll go nuts. I wanted to throw this slide in because this is an obscure thing that we do. Most people don't know about it. It's a fire weather. We do fire weather. I know that's a big deal in the western United States, but it's a big deal even here in Kentucky and southern Indiana. We work with partners such as the Division of Forestry, Hoosier National Forest, Wildlife Refuge, the National Park there at Mammoth Cave, Fort Knox. We issue a lot of different forecasts. We issue spot forecasts if they want to burn a bunch of stuff to get rid of loose timber and loose limbs and things to prevent a major fire from later on going. These are our seasons. So that's just something that most people have no idea that we do. Actually, there's people in the Weather Service called IMETs, incident meteorologists, that go deploy with fire crews. We had a guy in this office that worked here 30 years that deployed on fires, Joe Ammerman, that did it for years and years and years.
John, we have a great CoCoRaHS Weather Talk webinar on fire weather if folks want to look at that. It's archived on the list. It came out a year or two ago, and it goes into a lot of detail. So. Okay,
thank you. Okay, the next slide is the forecast tasks. There's a lot of parameters here. I'll just go through them quickly. Temperature, hour-by-hour temperature, hour-by-hour dew point, the apparent temperature, which used to be called the heat index. Relative humidity is an automatic calculation with this stuff above. The max and min temperatures out 7 days. The wind forecast hour-by-hour, the wind gust hour-by-hour, the sky forecast. We have a lot of planetariums that use our information. Obviously, if it's cloudy, you might want to stay home. The weather, any type of weather, drizzle, fog, whatever. The POPs, which is the probability of precipitation. The thing I care most about in this office is the POPs and weather. The CoCoRaHS observers, I'm sure you want to know if it's going to rain tonight or snow, if you're in Rapid City, South Dakota right now. And then the bottom one is probably one of the more complicated things that we do, called the QPF, which is the Quantitative Precipitation Forecast. That is very problematic. Yesterday morning, parts of northern Missouri got, what did they get, 9 inches of rain. There's no one that I know that would forecast 9 inches of rain, unless it was a tropical system like Katrina coming in. You'll put 20-inch bullseyes. Okay, I understand that. But when you get some very, very heavy, deep convection and storms, either backbuilding or they're just slow moving, you can get some astronomically high rainfall rates. And if you see us put in 3 inches, that's a lot of rain. I don't think you'll see anyone put in 9 inches. I've never had in my whole career. But anyway, these are all the parameters we have to do out 7 days. We write forecasts, the hazardous weather outlook, the area forecast discussion. These are automatic generated, the area forecast matrices or the point matrices, we just published the forecast. Years ago, we used to type everything, gang. Now we draw it on that previous screen, and the words come from that. That's a huge change, just from the old days. Okay, we send the forecast out to the world. This goes out through the weather wire. It goes out through digital companies and private companies. It goes out through the weather radio. We actually phone record it. Here's Rick recording that. Here's the graphical forecast. These are all our weather radios in our jurisdiction. I don't care if you have a weather radio, gang, or you have One Call Now or Code Red. You need to have a service, to me, that will wake you up in the middle of the night if there's a life-threatening situation, a tornado, flash flood, whatever. Okay, then you got, at the end of the day, you're tired. You want to go home. So you got to brief the incoming shift. Here's Tom and Aaron doing that, and this is a picture and go home maybe. Well, maybe you won't. These are the supercells on Henryville. We're staffed for fair weather. When the weather's bad, we change our staffing plans. People are held over, brought in their days off, whatever the case may be. I got an awesome staff here that's very good at putting their names up on the board. And just for instance, we have 23 people in this office. On March 2nd, 2012, I think we had 15 or 16 people here on the day shift during the peak event of that. And that is the tornado right there. That's not what you want to see. All right, this is the hydrometeorological task that we do. There's an assistant that works with the forecaster to do a variety of duties. They collect data, rainfall data from the CoCoRaHS and from the Mesonet and from the co-op observers. They QC the data. They generate a variety of hydrometeorological data, such as the regional temp precipitation, the RTP, the CoCoRaHS product that goes out, the river stage forecast. Mike's going to talk about that in about 2 minutes. We issue a variety of products, the river forecast here, which Mike's going to talk about in just a minute. When there's stormy weather, the H&T works with the forecaster on all these river points. We have approximately 20 to 25 river points that we deal with here. The climate's a big deal. And as a state, I'm talking to the state climatologists in Colorado, but climate is a big deal. We got to get that information out and correctly. I have an awesome climate program leader here named Tom Ray. We've added a climate point in Frankfurt. We added one in Bowman Field, LOU. Our climate database goes well back into the 1800s. He has a tornado climatology page that has every tornado graphically depicted out to 1870-something. So that's another test the H&Ts have. CoCoRaHS, what a transition. This is just the stuff I use on when I go do my Rotary talks. I usually do one Rotary talk a month, and this is the promo I do. We need you. So all the CoCoRaHS observers on here, recruit somebody. Sign somebody up. If you know of a weather weenie when you're having McDonald's coffee in the morning, or you meet someone, if you're a farmer and you go to a farmer co-op, boy, we need your rainfall. We need more. You can see on this map that some counties are saturated and some are barren. Some counties are saturated and some are barren. This is an example of Franklin County, Kentucky. This is Frankfurt, and these are the rainfall on this particular day. Obviously, we have more people live near Frankfurt than out in the outskirts. So that's just an example of what it looks on our end. Okay, a I'm going to let Mike talk about this. This is where you take the rainfall data and continue. Here you go. Here's Mike Callahan.
Well, as you can see, we use CoCoRaHS data quite extensively, and I want to encourage all those CoCoRaHS people out there, even if it doesn't rain, please send in a report. I know a lot of people don't bother in sending reports on no precipitation days, and I myself am a CoCoRaHS observer, and I know how you can kind of forget to do that, but it's just important to let us know where it hasn't rained as much as where it has rained. But you can see on these two maps that we have a zoomed-in map that actually has the pointed or plotted locations showing our county warning area, and then we also zoom back and just show the state of Kentucky. And this data, again, without the CoCoRaHS data, our maps would no way would they be this detailed. So again,
and I'll tell you this is that TV stations use these maps. I've seen them on the air, and they get a lot of play on social media. So your data is going even on the media.
This is what we call our AHAPS page. It stands for Advanced Hydrologic Prediction Services. And this is the way we communicate the condition of rivers to the public. Again, this is my area of responsibility. The locations that have green squares or round or green circles, those are locations where we receive data. Now, a lot of people don't realize that the National Weather Service is also responsible for issuing all the flood warnings in the United States. Now, we do work very closely with the Geological Survey, the USGS, and the U.S. Army Corps of Engineers, and we could not do our job without them doing their job. We also work very closely with state environmental agencies, and out west, you have the Bureau of Reclamation and other federal agencies as well. But it is the Weather Service's responsibility to put out the flood warnings. So this is a way that we can get to the public what the current conditions of all the rivers are. And green is good. That means all the rivers are below, well below flood stage, and this is something you want to see. Now, the round locations are places where we can actually give probabilistic long-range forecasts, and we'll see that in just a second. So at the top tab there, you can see the real-time river observations. That's if you want to actually look at the data, and that's what's being displayed right now. You can look at what we're expecting all these places that we do forecasting with. You can see if we're predicting those locations to go above flood stage graphically. This is where you see the long-range predictions, and by long-range, I'm talking out to 90 days in some cases, looking at the probabilities that you're going to have a flood based on the current climatological conditions. So if you click on any of those points, what you will see is what we call a hydrograph. This is a location up in Indianapolis area, actually. But you can see the blue line is what the current observations have been in the past. The little dashed vertical blue line is now, and the purple line is what we forecast the river to be. So in this case, you can see that this location has risen above what we call our action stage, and that just means that this has given somebody in that community some concerns, but it's going to stay below flood stage, which is where the orange area begins. So in this case, there would be some concern, but there would not be any public warning. If we ever predict a location is going to exceed flood stage, we will issue a public flood warning. And we have 3 levels of flooding. We have minor, moderate, and major. Also on this map, you can see lots of information here. If you want to determine what this elevation is in mean sea level, what you have to do is down here at the very bottom of the, we call this a hydrograph, by the way. You'll see a number there. It says datum. You just add this value up here, looks like 9.74, to this value down here, 465.59, and that will tell you what the sea level elevation of the river surface is going to be. And this location, it's a USGS location, and we like to give the USGS credit, and down in this area right here. So again, this is at a fingertip, can tell you everything you need to know about what's going on at the White River at the Newberry.
Okay, thank you, Mike. Okay, just got a few more slides left. I hope you're all enjoying this. Weather radio used to be those 8 tracks. Now we have everything done. It's basically that automated voice you hear. You hear Craig or Donna or Tom on there that they never go home. It's just an automated voice. And this, we send out the tone alerts, the 1050 tone. And this, in this case, we have, you see these IDs. We're all big into IDs. This is Louisville, Bowling Green, Lexington, and Horse Cave, Kentucky. We actually still take OBS here. I know that will please Henry and Nolan. We still have different rain gauges up front, our thermometer out there, our maximum cotton region shelter. So, and I bought a special Davis system here because I want an anemometer here. I've been wanting for years to report a wind gust here at the office and send it out on a local storm report. And if any of you have a Davis or Oregon Scientific Weather Station or whatever, there's a NOAA app. You can send in your data. That will get right into our system and is gold. We actually have a weather CoCoRaHS observer who's in Frankfort, Kentucky, who has a webcam that we use, and he's got his snow gauge, 2 different snow gauge cameras that we look at. He's a huge help to us. Another task they have to do is they assist the forecasters. They answer the phones. They update the social media. They issue the local storm reports. There's an example of an event from July 27, 2012. Half-inch hail, thunderstorm wind damage with some trees down. Trees blown over on the power lines. Dime-sized hail. Here's an injury due to lightning. 67-year-old female was struck by lightning in a field. Like I said, Facebook, Twitter, et cetera, et cetera. Here's our operations area. 2 forecasters. This is our old model. We've kind of updated that since there, but there's 2 forecasters on duty. Sometimes there's a day shift has 3 usually, evening has 2, midnights have 2. But on a big event, this whole room is totally saturated because it might just look like this. There's an event from several years ago. We have multiple forecasters. There's yours truly in the middle. Or sectorizing. We have one area that may cover the north. One forecaster may cover the south or east or west. One will cover squall line. One will cover supercells. One will handle the flash flooding, phone calls, whatever the case may be. Here's some websites. Henry asked me to put some websites together, which with this presentation he's going to put up on his website. The weather.gov I mentioned earlier, you just go weather.gov/Los Angeles, you'll get Los Angeles. Weather.gov/Denver, you get that over in here, whatever the case may be. The Facebook page, the Twitter page. We actually make YouTube now, which is becoming more and more popular, to put up some videos. We do a lot of public education. We do like I said, I try to do a rotary a month. Our Warning Coordination Meteorologist is out and about talking to emergency managers and partners. Our hydrologist, Mike, who just came through here, does a lot with the Corps of Engineers, USGS, and others. Other websites, you can go to the AHAPS page, water.weather.gov, and you get the National Precip page. There's the SPC page. Here's the National Radar Mosaic, the Hurricane Center. You get the graphical forecast from the nation here. These are all just cool websites. This will be in the presentation, so you don't have to copy this down now if you don't want. And this is just the last 2 minutes is my stuff. One of the things I care a lot about in one of my crusades is keeping kids out of cars that are hot. So I worked with a guy in San Francisco named Jan Knoll, and we came up with this campaign called Beat the Heat, Check the Back Seat. Never leave kids in a car. In about an hour, the temperature will go about 40 degrees. We're losing about 40 kids a year unnecessarily. So please help with this campaign and proselytize is not good, ever, ever, ever. So we have beat the heat, check the back seat, it gets hotter, drink some water, stay out of the sun, don't leave pets or kids ever in a hot car. That's me and Hurricane Katrina. I forgot to mention, when he introduced me, I flew hurricanes for 15 years out of Biloxi, Mississippi. That's me on August 29, 2005. That's Katrina. And I like sunny weather. So I'm going to turn it over to Nolan and Henry and tell me what we do next.
Thanks, John. Actually, Nolan's on vacation today. He's a long-deserved vacation up on Lake Huron, so hopefully he's listening in at this time. Could you leave that last slide up, or could you go back to the website? So the helpful websites there, if we could go back to that one. There we go. That's great. Just leave those up, and we'll take questions. I've got a quick question for you. I know a lot of people are probably wondering, open houses. Sometimes the Weather Service has an open house where you can actually come in and see the Weather Service. Do you guys do that, or is that happening around the country?
Yeah, that's a great question. That happens from time to time. There's two things about that. In this office here, we had an open house for emergency managers, our cooperative observers, and members of the media 2 years ago. I have problems with parking here. I don't know where to put all these people with parking. I'm very open to having one if the city would help me with parking and get people to and from. St. Louis did one recently. I heard they had almost 5,000 people. Every office is different. Another concern is if you have an event and you have an active weather day, we'd have to delay it to the next week, and just the logistics and everything is very complicated. But I support that big time, and all you CoCoRaHS observers, if you want to go visit your Weather Service office, please contact them, and I would think everyone would be amenable and open to that.
And you would probably list the open house on your website if you did have something event coming up.
Correct.
Okay, that's great. Another quick question: what is your typical? So your shifts, you do these rotating shifts. How many days on? How many days off? Do you work 7 days straight? How's that work for most of the forecasters?
I let my guys, we negotiated a alternate work schedule. They work 9-hour shifts. When you work 9-hour shifts, you get 26 extra days off a year to be home, which is a good thing, and they're more motivated. They have longer breaks, but they work 9 hours. Most people, it's generally either 4 or 5 on and then 3 or 4 off, or 4 on or 2 off. They work a stretch of, I believe, 6 midnights. The next stretch is 5. The next stretch is, I think then they get 2 stretches of 4. So they space them out. So it's a little different in each office. I mean, I like this better. But when I did it, when I was a rotating shift worker, I worked 7 midnights once a month. The first one looked like you were in a black hole, Henry, and then eventually you saw the end on the 7th one.
Thanks. Well, we're going to start taking some questions. I got one other question for you. The Fort Knox radar dome, is that gold-plated by any chance?
yeah, Gert Frobe is on there from Goldfinger. No, it's not. I wish it was.
Okay. Well, here's some questions coming in. We're getting a bunch right now. A couple of folks have written to us and want to know what happens to the weather balloons that you guys, or that are sent up from the Weather Service offices and the equipment on them. Could you answer that?
Yeah, great question. If you find one, there is going to be this little box that the balloon is attached to. It's called a radiosonde, and in the back right corner, you open that up, there will be an envelope in there, a plastic envelope where you can mail that through the post office free of charge. It will go to Kansas City, Missouri. They will rebuild it, and it will save the taxpayers a lot of money. Not the balloon itself, but the radiosonde. The balloon itself, they just drop across America. I've always wondered when I see one. I had a forecaster in Nashville one time that actually there was no wind whatsoever in August, 0 wind, so it went vertical up and vertical down and landed on a road. Next thing you know, we got a call about the hazmat crew was being sent out. They're worried if they're going to send out the bomb squad, and they're harmless. And in the winter, interesting, if you launch the balloon in Nashville in the winter, the winds will be probably 100, 120 knots off the deck. That balloon will land somewhere in the northeast U.S. Isn't that amazing?
Do you know how far? What's the farthest one you guys have found? Is there?
I do not know that.
No? Okay.
I have heard that an office in Wisconsin had found one from the west, somewhere. I don't know if it was Reno or which office, but I don't know the record. I just don't.
Sure. Well, we've got some more questions. Let's try to get as many as we can in here in the remaining time. We've got about 20 minutes to come in. Paul writes in, and Paul wants to know a little bit about fog. How do you evaluate fog? Who observes fog? Can you talk a little bit about that?
Yeah. Hi, Paul. Okay, there's different forms of fog, whether it be the radiational. I don't know does it say what state Paul's in?
He didn't put a state on there, so I'm not sure.
Each state is different. I mean, each area is different, and the most common type of fog is radiation fog, where you can just cool your dew point at night, your temperature down to the dew point and saturate it out, and you'll have some radiation fog. There's fog-prone areas, places like Chattanooga, Tennessee, that get a lot of ground radiation fog at night. Then there's places like San Francisco, which is the king of advection fog, where you have warm air over cold water, and you'll have waves of clouds and low fog coming in and out. Another type of advection fog that you get that's just, I think it's the worst fog on earth, is, if you've ever seen this, Paul, if you have a big snow, let's just say it's in Denver for the sake of argument, and then the next day it warms way up. So you have 6 inches of snow, next thing you know you're in the 50s. You will get the worst, nastiest, it looks like something out of Dracula or Frankenstein, the worst fog you've ever seen on earth, and that's a real bad warm advection fog. I worked in Germany for 3 years with the Air Force, and I remember one time where the visibility for 4 days in a row, we never went above a quarter mile. That's how bad it was. Other types of fog, you get what I call precip fog, when a system is real slow moving in the fall, where the temperature and dew point are near or saturated out, and it's just low clouds and fog. You can get what's called steam fog over the Great Lakes, which is the warm air right just sitting on top of the, or cold air rather, excuse me, right on top of the warm lakes.
John, is that like I remember watching a couple of Chicago's Bears games, where they've had, you could hardly see the players.
That's right, the Fog Bowl, 1988, one of the greatest games ever.
You remember?
Yeah, that's really wild. And then you can get some Arctic sea smoke fog. There's various forms of fog. Most common is radiation. How we diagnose it, here in Louisville, UPS, a guy named Randy Baker came up with this equation called the crossover temperature. He looks at the maximum dew point during the day. Let's say for the sake of argument it's 60 degrees, and then you look at what are the lows at night. If you forecast a low where at the same temperature as the max dew point during the day, they worry about fog that night. Then they have to look at other parameters. How much wind's going to be? Is it going to mix out? Is it going to be cloud cover or whatever? That's a great question, Paul.
Thanks. So we've got some other questions here. Actually, here's one, and this looks like Nolan's sister out in California. Marilyn writes and says that she lives on the Pacific Coast. How do you monitor weather coming in from the ocean? Do you send up weather balloons out in the ocean? What does the Weather Service do for systems like that?
That's a great question. Well, there is some balloons from time to time. You have balloons in Alaska and Hawaii, Japan, whatever. However, that's not going to do it. So what do? We use everything from buoy data. There's buoys all across the ocean. We have sounder data from satellites to look down. We look at ocean temperatures from various gauges or buoys and other places. Satellite by far is the greatest asset of all. The hurricane hunters, my old unit actually flies winter storms off Alaska and Hawaii in the wintertime to try to help the forecasters at the Weather Service offices in Portland and Anchorage and Seattle and the Canadian Met units that have to forecast for British Columbia. So we don't have as much data. However, there is enough data with these other sources that I just gave you that help with the entire model solution. So that's a great question.
Okay, here's a couple more. Here's one from Chuck in Indiana, and he wants to know, why are the forecast discussions more detailed at different Weather Service offices? So as he reads different ones around the country, some go into more detail. Is that what's going on there? Yeah,
Chuck, every office has a different philosophy. Here in Louisville, I'm a huge believer in the area forecast discussion. Our office puts out a ton of them. Every office does things differently. I'm not going to, that's just like Chuck, you being the Indianapolis Colts owner and I'm being the Dallas Cowboys owner. You're going to do things different than I am. I think you'll see most offices do more of them as the time goes on in the short term. I think you're going to see more and more offices doing more updates throughout the short term and do what's called this ESTF, this Enhanced Short-Term Forecast process. And I get more compliments on the AFDs than just about anything. I hear we're very frequent, and that's the way I want to continue. I can't answer why every office does things differently. I'll tell you another good discussion, Chuck, is the SPC, the Storm Prediction Center, has fabulous discussions, fabulous, on their convective outlooks and on their MCDs, their mesoscale convective discussions. Another one is the NCEP Winter Weather Desk, the winter weather products that you can get on the web. Fabulous detail. If you're really a weather weenie, you can learn a lot from them. So that's the best I can answer that.
Hey, Jim in Missouri writes that he not only reports his CoCoRaHS precipitation, but he enters 24-hour temperatures such as high and low temps and stuff. How helpful are these comments, this auxiliary information that people put on with their CoCoRaHS observations to the Weather Service? Do you guys look at that stuff? Is that helpful?
Yeah, Chuck, I used to work in Missouri. I appreciate you doing that. Yeah, we look at that for verification in our numbers. That's used in this program called Boise Verify, where we look at our forecasts and the model's forecast, and we try to get as many points as we can. Years ago, Chuck, we just had the airports, basically, the ASOS. And now we have AWOSs, which are the FAA version. We have, in this state at least, we have the Mesonet. We're always looking for calibrated temperatures. And Chuck, I would encourage you, if you have that, to contact your local Weather Service office and see if they're willing to have you be a co-op observer, since you already have a lot of the good equipment. And we're always looking for good observers. So he doesn't say where in Missouri he's from?
I don't see it on there, no.
Okay, so wherever you are, Chuck, just contact your local office, and if you're willing to do it, man, we need as many good folks as we can.
Okay, here's one, actually two people writing on this. We got Kathy in Northern Illinois and John, both of them asking similar questions. John wants to know, can you volunteer at a National Weather Service station? And then Kathy wants to know, how do you find out where your local Weather Service office is located? So the two things that are kind of related.
All right, John in Ohio, I take 3 to 4, 5 volunteers in the summer. They have to be in college in meteorology. So if you're not a college student, you think, well, what can I do? In our office, we have volunteer ham radio operators that run the Skywarn net. If you're a ham radio operator in Ohio, I don't know where in Ohio you're from, is the Cleveland office or Wilmington, that's a good way to get in, where you can actually be a huge help to the office and get reports, gather reports. It's not just social media. I'll take ham radio, I'll take Morse code, whatever you can get. In the summer, I turn away so many meteorology students because I just only have so much room here. When I went to school, I don't know about Henry, but when I went to school, there was like 18 schools that offered meteorology in America. And now there's, boy, in the 60s. So there's too many meteorology students being put out for the number of jobs. So these kids that volunteer have a very big advantage to get hired compared to someone who doesn't. Now, Kathy, how do you find out where your local Weather Service office? Well, the easiest way is to look on a map where you are and look at that first slide I had of the offices and look at your county, and you'll see where you're located. I don't know particularly where you're located in, was it Illinois, Henry?
Yeah, she's in Northern Illinois, so probably Chicago area somewhere.
Chicago or possibly Davenport. I just don't know exactly where you are at. But, there's 122 of these.
She says Lake Country here on her. She just wrote it.
Okay. Well, I guess that's Chicago, right?
Yeah, I think so.
You can contact, if you need any information, whatever, you can contact the Chicago office. And Ed Fenelon's a good guy. He runs the office up there. You can contact him.
Okay, here's one from Larry in Kansas. And Larry wants to know the forecast you guys put together for an area. Is that a compilation of all the thoughts of the group in the office, or is that from one employee? And so how do those put together?
Great question. Yeah, We have two forecasters on duty, a short-term forecaster, which owns the first 3 periods of the forecast. So what is today? Today's Thursday. So they'd have Thursday night, Friday, Friday night. And then Saturday through day 7 would be the long-term forecaster. However, on a major event, it's a collective effort of all the staff in there, and they bring in extra bodies on a winter storm. Our science and operations officer will be involved. They'll say, well, I need you to look at thermal profiles. I need you to look at frontal lift. I need you to look at what snow ratios, whatever the case may be. Everyone will work for the benefit of the official forecast. Years ago, it was kind of my forecast, and it's more we now, and it's a team effort. And when the forecast is not working out, we need to update it, and will be updated. So I hope that answered your question.
Bob in Michigan writes that up in Michigan, a forecast of 1 or 2 inches of snow is fairly commonplace, but he notes that in the southern states it could be quite alarming to the population there. Are the forecasts handled differently than they would? So a place where weather is expected, a place where it's not expected, is that handled differently?
Yeah, Bob, that's the best question yet. Years ago, the Weather Service was tied to criteria. I told you a little about that earlier. Now, impact is considered. I grew up in snow country in western New York. I know about snow flurries and snow squalls and lake effect. I've spent most of my career in the Mid-South. I've worked in Oklahoma and Jackson, Mississippi, and Huntsville and Nashville and Springfield and Louisville. And there is no question that 1 inch of snow in Traverse City, Michigan, and 1 inch of snow in Louisville they're not even on the same planet. An inch of snow in Louisville can close schools. An inch of snow in Traverse City will do nothing except, minor inconvenience. It's the same thing for the people in the north. When you have when you get up in the 90s in Caribou, Michigan, or International Falls, or wherever up north, it's terrible because a lot of people don't have air conditioning. But the way they handle the snow in the south is that when we start to get into criteria, getting close to criteria to issue a warning, we'll do conference calls with our partners. We'll have 200 school superintendents on a call, along with media and power companies and everyone, about our thoughts on the latest forecast. And we'll update this forecast pretty frequently during the event. Whereas, a couple inches of snow up in Michigan or Wisconsin or Maine or Vermont, it's probably not going to be a big deal.
Okay, thanks. Roger writes in, and he says those radar domes that you guys have, are they able to withstand hurricane winds or even tornado winds?
I don't know off the top of my head what they're built to. They do withstand hurricane force winds, yes. I just don't know there was one that came down years ago down in Texas from a microburst. I would be lying if I just don't recall what the exact wind speed was. It seemed like it was down towards Del Rio, Texas. I just can't remember. Can they withstand a hurricane? Absolutely. I don't know what the peak wind is on the tower. I'll get back to you. If you get me your contact, Henry, I'll get back. As far as tornado, a small tornado, there would probably be some damage, but a bigger tornado, they're going to obviously have some structural problems. How much, I just don't know. When our radar goes down, I want to say this real quick on my answer. When we lose our radar, that's a big deal. However, we have other radars that we use here in Louisville. If we lost our radar, we would use the terminal Doppler, which is the FAA radar, which is in Mount Washington, Kentucky. And we'll also use surrounding weather service offices such as Jackson, Wilmington, Nashville, Fort Campbell, whatever. And we'll use those to supplement the problem that we're facing. Obviously, plus we'll call electronics folks, and we had a lightning strike last week. Radar was down. They had it up within 24 hours. They had a significant amount of damage down at the radar, and they got it up. And that's what I'm saying, what I said earlier about the importance of the electronics technician.
John, we've got a couple more questions coming in. Can you stay on for another 15 minutes if we go through these?
Far away.
You're okay? Okay, great. Great. Hopefully,
I told you I'd be here for you, Henry.
You're quite the guy. I appreciate that. Hey, here's one here that Bob in Broomfield, Colorado writes. He says he sometimes chuckles when he listens and reads a forecast and hears spotter activation is not expected, and there are forecasted storms. So he wants to know what criteria is used to determine whether or not spotter activation is declared.
That's a good question, Bob. If you're expecting garden variety thunderstorms, and let me define garden variety, a thunderstorm that is basically an up and down storm where you get a little bit of wind, you get lightning, and you get a bunch of rain. And then it peters out and it dies off, and you get some mid-deck and high-deck clouds. We're not going to activate people for that. What we try to look at is we look at the thermodynamic profile. In other words, those balloons that I talked about earlier. We look at the wind fields, and we look at the shear profiles from the wind fields. In other words, is there wind turning with height? Is it changing directions? Is it changing speed? And we look at the profile, how much moisture, how unstable is the atmosphere. We look at some strange folks. I'm trying not to be technical during this talk at all, but we look at things like lapse rates. What's the temperature between two levels compared to normal? Is it steeper? Is it not as steep? Is it how much energy, if a parcel of air can get as warm as the atmosphere, how much buoyancy can it lift to? So we look at all these parameters, Bob. And on days where we expect a line of thunderstorms, like a squall line, it's going to produce 60 to 80 mile per winds, we're going to say spotter activation is probably going to happen. Or if we expect what's called supercell thunderstorms, which are rotating thunderstorms that can produce enormous amount of hail, very dangerous wind, and tornadoes, we're going to activate on them. We try to put the activation if we're expecting very strong or for sure severe thunderstorms. If we are, what we try to do here in Louisville is spotter activation is expected on Friday night due to blah, blah, blah. And we try to give you as much specificity as I can. But yeah, if you hear thunderstorms in there, it won't always say spotter activation.
Okay, thanks. Here's a loaded question, seems like, from Nancy writes, and she says, you guys work with TV weather people. Do they have any input to putting into the forecast, or are they just performers out there? Okay,
I'll answer that, Nancy. That's legit. All your questions are legit, gang. I'll answer anything I can answer. The media has is there. They're going to be there for ratings ultimately. Now, I have a lot of friends in the media, and they want you to watch their station. Each station has a different philosophical belief of how aggressive or not aggressive, how much social media, how little social media, whatever the case may be. They are, years ago, you had people like Diane Sawyer, who did the weather in Louisville. She didn't know anything about weather. David Letterman, Indianapolis, he didn't know anything. Pat Sajak, Nashville, he didn't know anything. I mean, Willard Scott was the first Ronald McDonald in America. So now you have the vast majority of stations across America. There are exceptions, but the vast majority have meteorologists that are trained. Some go to get a meteorology degree, some get a broadcast meteorology degree. And some have, like Gary England in Oklahoma City. I mean, he was the one who brought his own, he was the first station in America, I think, that had their Doppler weather radar. They used to yell street numbers. I can remember that when I was in Oklahoma. They have a dedicated bunch of storm chasers that go out with their staff. There are people that deploy now at James Spann at 3340 in Birmingham that go out and take their van out that's got weather equipment all on their station that go out there to get you the latest and greatest. And some totally rely on the weather service. Some rely very little on the weather service. We just want to make sure at the weather service that we have a good partnership with all the stations, that we listen to their concerns, their requests, their comments, their feedback, and I make adjustments. When I was MIC in Huntsville, the media had a profound impact on how that office was going to serve and do our customer service. So it is kind of a loaded question, Nancy, but I mean that's pretty much the straight answer, I hope.
Well, thanks. We're going to try to jam a couple other questions in here in the next 5 minutes, so maybe we can go quickly through these. One of the questions here, where was it? How high in the atmosphere, Bob writes, does a weather balloon go into? How high up will they go before they fall
About
back to the Earth?
100,000 feet.
Okay, well that answers that one. Here's another one here that Elizabeth writes in, and she says that you mentioned using the Space Weather website when checking everything at the beginning of a shift. How is that information used in forecasts? And it's actually Beth in Omaha, Nebraska.
Okay, Beth. Personally, if I knew there was going to be some solar activity, we might get a bunch of media requests. That would just be for situational awareness. I probably use the Space Weather Center the least of the national centers, but if I knew there was something going on, you always want to be prepared. Well, just like this phone call, I'm getting questions that, I have no idea what to expect. But when you on shift in the middle of the night, if the police get all these calls about a meteor or a strange light in the sky, it could be a meteor, they'll call the weather service. So you always want to be up to date on what's going on, so you try to have an answer or whatever you might get.
Great. Mike in Denver writes, and is there a way to be notified, a mobile app, a text message, when a new updated area forecast is posted? He says he follows Twitter feeds but have not found a good notification service on this.
You know, our social, on our site, I'm not sure ours. I'm sure there is some sites. I don't know of an app that will do that. Email me, Mike. I just don't know right off the top of my head. I'll try to find that for you.
Okay, and our last question of the day, and you mentioned a little bit about this at the beginning, but Sharon wants to know what made you decide to become a meteorologist. Maybe you could quickly go over that.
My house was hit by Tropical Storm Agnes when I was 6. We had 50-mile-an-hour winds, 15 inches of rain. My neighbor's boat sank. I grew up on one of the Finger Lakes in western New York. I loved it. I thought it was the greatest thing I'd ever seen. There was no Weather Channel. There was no Doppler 8000. There was no internet. There was a special on TV on the hurricane hunters. I told my parents when I was 6 years old that I want to do that. I want to fly hurricanes, and God blessed me richly. I got to do weather, and I got to go with the Air Force Reserve. I did that for 15 years. I flew 3 Category 5s in the last 3 years. I feel like God blessed me big time.
You know, it's amazing, John, how many of us in the field of meteorology have had an event in our childhood. You know, I just think over and over again, people I talk to, that something happened that they knew early on this is the field they wanted to be in. And so,
yeah, I mean,
very, very much so.
Like in your state, Big Thompson.
Oh, yeah. Even last year. Last year on this date, actually, September 11th, we had the floods that went through the Big Thompson Canyon as well. So, yeah, indeed. Well, look, we're just about out of time for today. Bob, John, I want to thank you so much for coming on. This is an excellent webinar. Thanks for taking time to answer the questions, and hopefully our paths will meet again at some conferences as we travel around the nation.
Okay, Henry. Thanks for having me.
Well, thank you. And to the folks out there, I want you to please join us for our next CoCoRaHS Weather Talk webinar. That'll be, mark your calendars, Thursday, October 23rd. This webinar will feature the director of the Center for Western Weather and Water Extremes, Marty Ralph. And Marty will talk about atmospheric rivers and whether those are those relatively narrow regions in the atmosphere that are responsible for most of the horizontal transport of water from outside the tropics. Fascinating stuff. You want to sign up for that. We'll have that on our website shortly. And before you leave today, when signing off, please take our survey. Again, it'll pop up on your screen. Well, so until next time, this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now and have a great afternoon.